Hello everybody, and thank you for joining me today in this class on the subject of GIS and BIM. So in this class I'll be explaining the principles of GIS and BIM and showing you how to get digital geographical data and use it in your project. My name's Ian Robinson and I'm the infrastructure consultant here at Greytec. I'm based in the UK, but for our international delegates you'll still be able to use all the principles in this class, as there's no fundamental difference between the nations when it comes to GIS data other than where you get it from. Greytec are the market-leading multinational company that provide customers with the tools, training and consultancy to design, simulate, fabricate and manage construction and manufacturing projects. We provide basically all the necessary tools and knowledge to ensure BIM compliance. Now this presentation is aimed at the Greytec design and manage stage of BIM. It's a vital part of the BIM process is to ensure that you procure, create, manage and share data of all kinds. And some of this data is called GI data, or geographical information. You may have come across terms such as GIS. Well, that refers to the technology that manages the data, geographical information systems. This class is a beginner's guide to GI data and how you can handle it in the AutoCAD software. It's aimed to show you what GI data looks like, what formats you're likely to come across and how you can use them in your BIM projects. So I'm based in the UK, so we'll be mainly talking about UK data sources, including data based on the EU directive INSPIRE. That's basically a project so that all across Europe, and this includes EFTA, the European Free Trade Association nations, and some non-EU nations. But all across that Europe, government agencies are giving access to their data, basically. In fact, it's happening all around the world. This image, by the way, is your BIM world, so that'll crop up later on. So let's just start with what BIM is not. Okay, BIM is not Revit. In fact, it's not software at all. There are software packages out there such as Revit and Bentley and Civil 3D and InfoWorks, to name just a few. These are excellent packages to use in your BIM process, but they in themselves are not BIM. And it's not buildings either. I mean, admittedly, we don't actually help ourselves, do we? We're calling it building information modelling. And to be fair, images like this from Autodesk don't really help the cause too well either. So let's think of BIM as building, as in creating, putting together. Information as in data, facts, knowledge, and modelling as in data modelling or even managing. It's all about the data. And sometimes that data is a 3D model, but it can also be a spreadsheet. It could be a spatial file, which is what we're talking about today. It could be a CAD file, project plans, timelines. It's all really about the process. It's about making the process of building things more efficient. BIM Level 2 is about having a common data environment that's fed by your data and therefore a source for data for the whole project, including your 3D models. The key deliverables are 2D documentation derived from the 3D models themselves, and COBie data. And this is where we're at. We're at BIM Level 2. The CDE will consume data that includes 3D models and any other data that includes your GI data. You can then interrogate the CDE and produce information from it. I'm mainly talking about the consumption of data in this presentation, but this also feeds the output. So it's also a vital part of the 3D model and our COBie. So when it comes to spatial data, what are we talking about? Well, we all know digital data, it's just a load of noughts and ones, but what you're familiar with is the organized data, such as databases like Access and smaller databases such as Excel, or even data files like CSV. Well, spatial data's no different at all. It's exactly the same stuff, but it has information about their place in the world. It could be anything from a simple X and Y coordinate. If we just have a look at that the CSV file from the last slide, it's just got an X and Y coordinate on there. But it can go right through to complex 3D dimensional geometry with lots of attributes and overlays, etc. Which software is best to consume, analyse and manage spatial data? Well, there's a whole load out there. Top of the tree in terms of sales is probably Esri. You may have heard of terms like ArcView or ArcGIS. These are Esri platforms. The file format Shape is an Esri file format. You may have come across that. So is a personal geodatabase. It's actually a Microsoft database, but it's packaged by Esri. There's File Geodatabase is another new one as well by them. Other providers such as MapInfo. This is a product by Pitney Bowes. I know that is the franking people. You'll come across tab files or MIF-MID files, stuff like that. Another organisation that's relevant around the world is CAD Corp. These guys, although they do have their own format, they advocate open standards so they can consume many formats. In fact, most of them, certainly the ones you'll have come across. They work closely with the Ordnance Survey and with the OGC. That's the Open Geospatial Consortium, who support international interoperability standards for geospatial systems. And there's free ones out there as well, the best of which is definitely QGIS. I use that one. So the good news for you is that Autodesk also have GIS tools. I'm not going to go into all them tools today, after all it's a beginner's guide. But I'm going to show you where to get the data, what you can get and how you can use that in Autodesk products. As I've already said, I'm using data based in the UK, but for our international delegates, just talk to your country managers about what's available locally. So with the Autodesk software, if you're an AutoCAD user, as of 2018, you may be aware, I've shouted about it enough. Instead of downloading AutoCAD 2020 or 19, you could download AutoCAD Map 2020 or 19 or 18. And that is AutoCAD. It's got everything AutoCAD has. You can even make it look exactly like your old AutoCAD, but it also has geospatial tools. So you can import, export, view, do all sorts of stuff in there. If you're a Civil 3D user, you may be aware that AutoCAD Map 3D is built into Civil 3D, so you've got all the tools you need. And InfoWorks as well, which is basically a database anyway, it's a spatial database. Can also consume this data. All of that can go straight into your BIM world, so any of this stuff, just add it to your project and your BIM world is fed. Even better news is that Autodesk and Esri have entered into a development partnership. If you missed it, Esri held one of the opening classes at this conference on Tuesday, and it was brilliant, showing you that you can place your Revit models into their enterprise solution, giving you a brilliant platform for sharing your information. So if you did miss it, all the classes have been recorded, so go and have a look for it. If your organisation or the project has ArcGIS package and is producing mapping information, whether it be just for your company, the whole project group, or even the public, you can now connect to the Esri database and the cloud services and view, manage and even edit that spatial file. So I'll be looking at it from one side, going into the database and taking that information out, and the Esri presentation is going in it from the other side and taking the Revit models and BIM data and putting that into their spatial world. So there's a real good link between the two there. Now it'd be a little bit remiss of me to talk about data without talking a little bit about risk. Spatial and non-spatial data, they've got the same risks involved, but with spatial data there's an additional risk. In terms of security, file sharing has its own risk, doesn't it? But the same goes for cloud storage, probably less so, but you've probably got less control over that security. No, the biggest risk that I'm talking about is understanding the data. We can reduce a lot of problems just by understanding where the data comes from and what the data is reporting. Spend time to understand what the data is telling you, when it was collected, is the information relevant to you? I know this sounds crazy, but if you want to know how an area floods, for example, should you be looking at flood zone 2, flood zone 3, 1 in 30, 1 in a 100 year surface water? Should you be looking at speed or depth? It really is a minefield. All the information is out there though. You just need to make sure that you read it. So what data is out there? Well, there's loads of free sources. Those of you that have used InfoWorks will have seen Model Builder, hopefully. This supplies Bing maps, aerial imagery. It's the exact same aerial imagery you get in your AutoCAD products. You also get buildings, roads and coverage areas. All of that comes from OpenStreetMap. It's a free to use crowdsourced data set. The landform that you get comes from two sources depending on how far north you are. Basically, if you're above the Shetland Islands, you get, or the Shetland Islands and above, you get a different data set. It's actually newer, but anyway. The rest of us get data that's been sourced from the USGS SRTMGL1 dataset, which was gathered by the Space Shuttle Endeavour back in the year 2000. So it is old, but of course we're talking about the wider area. We're not talking about your actual project. So it's a good starting point. Also, with that new partnership with Esri and Autodesk, there's some sources available on the ArcGIS server. Now be careful here though, because the freely published data has got no real guarantee of any sort of quality control, and documentation is limited if available at all. I mean, there are exceptions. Esri UK have published some good data up there, but you'll find loads of student data sets and test data sets and all sorts of stuff in there. You're best going to the source for that data, so don't treat that as a free data source unless you can guarantee the data. There's OpenStreetMap. I know I've already mentioned that because you get that in the Bing Maps, but you can go to openstreetmap.org and you can download that data. Now, as I said, it's crowdsourced data. It's got a good road network. Buildings, they're not bad in towns, and important buildings are usually pretty covered. But when you go to the suburbs and the villages, there's often not so much coverage on there. Ordnance Survey provide an open data portal as well. This is a great source for data. It covers the whole of the UK. You've got things like landform, you've got vector mapping, you've got raster mapping. It's kept up to date, and it's got one of the world's best data sources as its source, if you like. And then there's the open government data portals. Now that does deserve a little bit more attention, so let's just delve into that a little bit deeper. So INSPIRE, which stands for Infrastructure for Spatial Information in Europe, it's an EU directive that was designed to have a European-wide shared data set that feeds into EU environmental policies. For us, this means that you have access to this important data. It's a fundamental part of any construction project, really. Each member state, they've got their own portal access, and this includes the EFTA members, and 3 non-members are North Macedonia, Serbia and Turkey. So hello if anybody's from there. Just select the country and you get a link to your government website. There is a handy map as well, which is quite apt given the subject matter. For the UK, we're a bit unique though, because we're made up of nations. We're not just one nation. Here's Scotland's portal, for example. Northern Ireland, you need to speak to LPS or the OSNI. Wales, mainly that's on data.gov, but I think they have probably got a portal now. It's a principle that's not just European though. Of course, you know, nations around the world have a requirement to share data, and this one, for example, is the US government's open data portal. For us in the UK, it's data.gov.uk, and this is the site, and you can get loads of data in there. You can see I've highlighted environmental and mapping data. If you do a search, there's a nice little search there, Geospatial Data Catalogue, and from there you'll find links to the OS, HM Land Registry, the Coal Authority, the Hydrographic Office, the British Geological Survey, and we'll have a look at some of them shortly. Paid for service, obviously they're everywhere, aren't they? In the UK, one of the best products is from the Ordnance Survey in the form of MasterMap, which includes large-scale vector mapping. The vector mapping also includes building heights now, so keep an eye out for that. They have a layer for imagery, they have a network layer which has paths, roads, rivers, canals, stuff like that. Now they're all really strongly attributed. So on the roads, for example, you'll get things like speed data or routing data. In the topographical data set, you know, you'll be able to find out if it's a government building, you'll be able to find out if that piece of land is natural or man-made, that type of thing. So there's a lot of information in there. And there's other products as well other than master map, such as Vector Map Local, which is available in both vector and raster format. I know that's confusing. You can buy it from all sorts of places. You can get it in small chunks to any size you want, really, from any different supplier. Not just the OS data as well. There's lots of other data providers. Now at Greytec, we don't recommend any one supplier. Just find your favourite and pick them and stick with them, because they'll all be good. And on a final note, before I start talking about the Autodesk products, or showing you the Autodesk products, a little bit of info on the data. So there's a lot of products out there and it can get quite confusing. So here's a useful guide to the level of detail in various products. So down the left hand side are our highly detailed products, and down the right hand side are slightly less detailed products. Along the top are free, and along the bottom are paid for data sets, and each one shows their relative attributes. So basically the free stuff, the top row, you can see it's got very little attribution, whereas the paid for stuff has a lot more attribution and a lot more information. And of course the high detailed stuff, you're going to get all the individual buildings in master map, whereas when you go all the way down to vector map district, you just get one big block to show you that there's a block of buildings in that area. Okay, so let's move on and have a look at the products. Let's start with AutoCAD Map 3D, and this is it that you're looking at now. I mentioned earlier, it's just AutoCAD, isn't it? If I went to 2D drafting, workspace, those of you that use workspace will understand that. It's just plain old AutoCAD with this extra little whiz on it called a task pane, but everything in there is as you'd expect. I'll go back to my workspace. So we're mentioning about the data. So if you were going to get the Ordnance Survey data, you can download that into lots of different formats and work with it. I have it here in an SDF format. I've also got it in a shapefile. And this is the master map data. I just wanted to show you that. You literally drag and drop it in there. You can go data, connect to data, and there's a whole load of stuff in there, and we'll go through that as and when we need it. So here's all our mapping data straight from the OS. We can style it up. Obviously it just comes in as one thing, but we've got a lot of attribute data. These are all the attribute data, including building heights, which is really cool. So you can go and style it up by descriptive group, which tells us if it's a building, a road, and stuff like that. And we'll just put a theme on it. Pick the polygons and select a palette, and I have one in there that I've made for this, and we'll hit OK, hit OK, job's a good one. Now I mentioned it's all about the data, so here's a whole heap of data in here that gives us extra information about the mapping stuff. So for example, if I look at this area here, this bit of land here is under general surface. So is this bit of land, so is this the bit of land. They're all under general surface, but look, that one's natural, that one's man-made. So we can find extra information about the drawing over and above the master map data, the geometry if you like. So if I go into my styles, I could say, right, let's run a query. So queries are really useful. If I pick, I'll scroll up, general surface there, and I'm going to change the query. So at the moment it's saying, look, if the descriptive group is general surface, and I'm going to say and make equals, and if I do get values, man-made. Okay, so I've got that. I'm going to duplicate that now and go into the other one and say not equal to man-made. So if it's equal to man-made, let's make it grey, and if it's not equal to man-made, let's leave it green. So the attribute information can add additional stuff. Now on top of that, master map has a sites layer as well that you can get. So if I want to know about where the important sites are on here, again just drag and drop it in. This is a shape file, and we can go in and we can style that up, and we can say add a theme in based on its function. Hit OK, and then we've got, oh, I picked a rubbish colour there, didn't I? So based on its function, let's go and pick a different style. and we'll just use a standard kind of AutoCAD type palette. Don't like the black, let's change that. And there we are. And there's all our sites information. And we can search for things, we can zoom into things, we can find things. We can run queries and all sorts of stuff in there. So we can put postcodes in. So working with geospatial data is quick, it's easy, it adds additional information into your BIM process. And if you're working on a civil project, you can do even more stuff. So let's go to our civil project that I've just put in here. This could be Civil 3D, it could be, I'll show Civil 3D in a minute. And we've been talking about Esri, ArcGIS, and here it is. So here's a gallery of all the maps that I've created, and I've got an environmental map that I've created. It's got all sorts of layers in there, showing me where the flood is and all that sort of stuff. We can connect directly to ArcGIS connector. You get this map up here, which is rather nice. You just go and zoom roughly into where you're working. So Wigan, somewhere around Manchester, and if I hit that button there, it will say, right, what maps do we have in this area? And there's my content, there's my groups, because you can join groups, there's my organisation, and there's public stuff as well. The public stuff, as I mentioned, a lot of that's, you know, you've got to be careful what you're downloading publicly. I would always go to the source of the data. But if I pick my environmental map, it should tell me the layers. There's all the layers. So I've put flood layers in there, environmentally sensitive areas, rivers, habitats, all that sort of stuff, and I can just add it to my project. So that's connecting to ArcGIS, and you can see it on the right hand side there, just chucking it all in, and we should zoom out and get a whole massive area. Now this is a massive data set. It's a bit of Wales covered in there, all of the northwest of England, and in fact I think the Open Rivers data set is the whole of England and Wales. So let's just have a look at things like SSSIs and flood alerts. I'll just turn these off. Of course we didn't have to bring them into our project, you know, we have a choice, we can just turn them on and off as and when we like. Let's zoom into our project. There it is. That red rose marker in there, that's the geolocation marker, and if you don't like that you can get rid of it. The command for getting rid of that is geo marker visibility. You can see it there, geo marker visibility. Just set that to 0 and that'll go. And again the style, so if I wanted the flood alert areas, I can pick it, set the style. So regardless of how this data is set up on the Esri server, we can adjust it to suit the project that we're doing. Okay, and SSSIs, maybe they'd have been better green. It just picks a random, well I colour it in order actually, but it'll appear random. So there we are. So we can now see that our site does touch a flood alert area, and we can mitigate against that. We need to work against that. Right, I'm just switching to Civil 3D. To get the task pane on in Civil 3D, remember map is built into that. There's a button here, turn your map task pane on, or you can just type into your command line map W space, the word space, not the space bar, and it'll just say, do you want to turn me on or off? And you say on, and jobs are good. And you get the task pane in here. So on data.gov.uk we mentioned that you can go and find lots of stuff in there. There's the OS Open Data, remember? That's what that page looks like. So you can go and download where you want. So if I'm working in SD, I can go and download OpenMap Local, and I've got free buildings and free road data and all that sort of stuff. But we've also got things like the British Geological Survey. So if you want to see what that data is going to look like in your project, you can. So all you do is you go and you get, if I right click and copy the location of the WMS server, and then in Civil 3D in the map task pane, data, connector data, WMS, and just paste that in there. So that's now going to connect to the BGS website. You always get this username and password, they never have one on there. And you can see all the different data sets that are on their server. So if I want to know what the bedrock is, I will add that one, add it to the map. It's for the whole of Great Britain, I believe, this data set. And as I zoom in to my site, we should get a colour of the bedrock. Now if I want to know what information is in there, you can right click it in here and get WMS information and pick your site, and it tells you, there we are, carboniferous bedrock, swamps, estuaries, deltas, rivers, sedimental rock, etc, etc. So you can add the additional information. So on that one there, I can either get rid of it or just turn it off, and let's have a look at the environmental agency. So if we were to look at risk of flooding, so here's your 1 in 1,000 year data set, and I can do the same here. So this is risk of surface water depth, or this one is surface water, this is the data download, should I say. There's also one for speed as well. So again, I will copy this link, go into my data connector data, there it is, add another WMS. Ideally you should name them, because otherwise it just comes up WMS1, WMS2. So if I just do 1000, and I can paste that one in there, click connect, again no password. There's only one data set in there, we'll add it to the map. As I zoom into my map, we should get to see that data. It should just suddenly appear. There it is. I just had to move around a little bit. Yeah, and there it is. Let's just put the image underneath so you can see it a bit better. And the same thing, you know, if I wanted to see what the depth was, because they've all got different information, get the information, pick on there, and it tells us about the what the depth is in there. It does come through as HTML. You could just save that. If I save that and open it up as a web page, you can see there that the depth is greater than 1.2 meters at that point. It's actually where there's a little brook there. Okay, but clearly on our road that we're working on here, we have to be careful with the water, but actually on this site we're okay, because this end's high. If I hover the mouse, you can see the Z's at 40 and this end's low, Z's at 39. So clearly we obviously have to consider the amount of water coming off site onto the road. So again, early in the stage of creating our project, we're already answering really important questions. Let's have a look at some of the other sites in there. So back to this this page here. The download takes you to a data service download page, and in here we can download lots of different data sets. You can see that you can download full data sets, or just pick an area of interest, literally just go and pick an area. And you can download shape files, map info files, geodatabases, and map info tab files, so MIFMID and tab files. So there, map info, these two are Esri. You've got geographical markup languages, your kind of open standards in there, and then there's a JSON file as well, often using kind of web mapping applications, stuff like that. So yeah, you can download the flood data just for the area that you need, and then you've got that file. The advantage of the WMS is it's always up to date. The disadvantage is it will always be up to date. So if you want to create a snapshot in time, this is what the flood data was at this moment, then download the data and it won't change. Another useful site for downloading is the survey data download. You can see there environment.data.gov.uk DEFRA data download mode survey. And in here you can download Lidar data. You can basically take your area and just go and draw where you would like to get the information from, like so, and it will tell you which tiles are available in that area. Alternatively, now you know that you can output your area, so you can output this area here in fact I've got a bigger one here, as a shapefile. All you need to do with that is zip up the shapefile and then stick that in. So if I just go and find that shapefile that I've already downloaded, I've already created, should I say. Okay, here it is. So it's just a zip file with all the shape files in. Just drag and drop that in, and it's going to go and find where that is on my site. So once you've got your site, you can go and get the available tiles. It's now searching the OS stack of tiles to see which of them touch my site, and then it's going to give me back a list. And there it is. So the composite is the kind of up-to-date data set all merged into one. DSM is digital surface model. That has all the surface features in it. So it'll have trees and buildings and things like that. Good for large scale line of sight. And then DTM has got all the surface features stripped out, so it doesn't go over trees and buildings. It's just the ground model. So that's great as a ground model, obviously. And you can see they've got different resolutions. They actually go down to 25 centimeters in places. It all depends on, because obviously the Environment Agency and DEFRA are not responsible for mapping the UK, just the bits that they need. So you'll get varying quality, and in some areas there is no data, so just bear that in mind. But you can go in there, hit download, and it'll download as ASC files, which is an ASCII grid file, and then we'll go and have a look at them now. Right, so we're now in InfoWorks, the last one I'm going to show you. And again, you can just go and download a model using Model Builder, and as I mentioned earlier, you'll get roads, buildings, you get coverage areas as well, imagery and level information, and it tells you where that comes from, so there's no cloak and dagger there. And again, you can take that shape file. This time what you need to do is you need to just import these two files, the projection and the shape file. So if I just copy that location and go and import and paste that location, and I'll just pick these two files and open, it should take me there. There we are. So again, we can get to that data very easily, and then we give it a name, create a model. Okay, it takes about 5-10 minutes. Obviously we haven't got that, so here's one I've done earlier. So here it is. So there's our model. So it's got a bit of landform on it. You can see the kind of levels there. I've stripped out the roads. All I brought in, I turned off roads and buildings. I've just brought the landform and the imagery in. If you've never seen InfoWorks before, it's basically Planet Earth, and you stick your site on it and you work on it from here. So in here we can use that landform. Now you can also use it in Map 3D, and you can use it in Civil 3D, so it can be used all over. So let's go and find that data set. So I'll just go one level into the Lidar, and there's the Lidar files. So I can just pick them and just drag and drop them in. And the first thing that comes up is your data sources configuration. It knows it's a raster file. We just need to tell it's on the British National Grid, and we can click to the model extents if we want. For this data set, if you're working with it, you have to have a null data value. So they're basically raster files, just like images, which images have pixels with 3 numbers on them, RGB, red, green, blue. Lidar has the same kind of format, but instead of RGB, it's XYZ. So where there is no data, you still need a lump of data, a pixel if you like. So what they do is they tend to put in a null data value, and in this case it's -9999. What will happen then, if there is any area where they haven't got any data and it's at -9999, it'll leave a hole, which is what you want it to do. It'll actually infill it with the data that we've already got. Otherwise, you'll end up with like a massive waterfall to nearly 10 kilometers below the surface, which you don't want, do you? So let's hit close and refresh. Now it looks like nothing's happened, because in the later versions, you can see over here it's imported. What it does is it creates terrain surface categories and doesn't turn them on until you've moved them into a category. and you can create multiple categories if you want. If I turn that on and hit OK, just make a mental note of how that looks at the moment in terms of the quality of data. And when it rebuilds using this data, you can see immediately it's up to date, it's much more accurate. Yeah, and that's a 1 meter Lidar. Imagine what it's like at 25 centimeters. So we're starting off at the very early stages of our BIM process, and we're utilizing data that's available for everybody in the project using all the different products, and that can continue throughout the life cycle of the project. And of course, if you're using Esri ArcView, then you've got a single source for all your spatial data that can be plugged in to your BIM project via InfoWorks or via Map3D, or your BIM project can be plugged into your ArcGIS server. So it can go either way, really. Really powerful stuff. Now let's just carry on. We looked at buildings, and I just wanted to quickly show you that we can work with the buildings as well. So I downloaded a load of buildings. This is from OS Open Map Data, so it's not the stuff you buy. You just drag and drop the shapefile in. So this is the same stuff that can be used in Map3D, in Esri, in MapInfo, in CAD Corp. We can also use it in Civil 3D, and we can use it in InfoWorks. One single source of data. So these are buildings. We'll just put a random, well, put them at 6 meters. Make sure they're on the British National Grid. Drape them to the surface. When you download the buildings, you get the whole of SD. It's humongous. It's a massive, massive data set. So always clip it to your model. And we should just get some buildings in there. So again, this digital data is going to be utilized throughout the life cycle of the project. It's a single source of truth. And if you watched my latest webinar on InfoWorks, this is the site we worked on. And we have a nice finished site. I'll just show you it actually. Finished model with a Revit model in there, with the OS buildings, with flood data and road data, and then our design in there as well. And there we are. So that's utilizing Revit. That's a Revit model, and there's our design that we've been working on. So yeah, very nice. Using digital data in your BIM project is going to add so much more value. Okay, I better shut up there, and it's now a good time to do some questions and answers. So if anybody has any, please feel free to pipe up now.